Okay, hello guys. As we'll continue with our videos, we are still on the nature of roots. So basically, what we're going to do now, we're going to explore examples. So I told you that these questions, they can be asked in three ways. So the first way that can be asked is when they say determine the nature of roots without solving the equation. So basically, we need to determine the nature of roots of this thing without solving an equation. So since you know that, first you need to know that your delta is equals to b squared minus 4ac. Is b squared minus 4. So you have already written your notes. You have already written that table that I've given you. You remember the table that I've given you. Make sure you have it alongside. Have your table, that table that I've given you. Make sure you have it alongside you so that you can know what we're talking about. Okay. So now you have to know from your equation. Make sure always that your equation is in the form of ax squared plus bx plus c. You must always see this thing. When you are going to discuss your nature of roots, you must always see ax squared plus bx plus c is equals to 0. Make sure you always see this equation. Okay, firstly, do I see this kind of equation here? Yes, I can see it. So what you can do is find the value of a. We know that our a is 2, and then my b is what? It's 5, and then my c is what? Is 10. So we are not solving any equation. So now we have to substitute there from our delta. Our b, my b is equals to 5. So it's going to be 5 squared minus 4. And then what is the value of a? And a is 2. And then what is the value of c? And the c is equals to 10. Then how much are we getting? Then you can punch in your calculator. When I punch in my calculator, I get minus 55. I get the delta, which is minus 55. Okay, you get the delta that is minus 55. So it means this delta is less than 0. You remember, then you go to your table. Look at your table. When delta is less than 0, it will tell you that the nature of this root, they are what? They are non-real roots. I told you that when they are non-real roots, we cannot go any further. So when delta is less than 0, they are just non-real roots. Okay, that's example number 1. Okay, let us check example number 2. Now I'm going to do example number 2. Example number 2, let me just write 2 here. So example number 2, so basically we can say we have 3x squared minus 3x minus 1 is equals to 0. Oh, is it in the form of ax squared plus bx plus c? Yes, it's in the form of ax plus b plus c plus c. Yeah, it's in the form of ax squared plus b c. Like what numbers? Okay, so basically we're going to find the value of a. 3, what is the value of b? Minus 3, what is the value of c? Minus 1. Now we're going to find our delta. So my delta is going to be b squared minus 4ac. And then what is my b? My b is minus 3 squared minus 4. What is the value of a? A is 3. What is the value of c? C is what? It's minus 1. So you can just punch these things. You can just punch this thing on your calculator. So basically, when you get 21. You get the delta, which is equals to 21. Okay, 21. Let us see. 21 is greater than 0. Basically, you check your table. We're going to analyze everything that is on the table. So delta is greater than 21 is positive, so it means delta is greater than 0. It means that we know that this thing is real. But you know, with real numbers, we have to go further. So real numbers is either they are rational, and then once is rational or irrational, they are unequal roots. So we have to know 21. Find the square root of 21. We cannot get the square root of 21. So it means also this delta is not a perfect square. You see, this delta is not a perfect square. So this delta is not a perfect square. So since this delta is not a perfect square, it means the roots of these things, they are what? What you're going to say is the roots of these things are real and what? Irrational. They are real and irrational. And then what? unequal. They are real, irrational, and unequal roots. Then we will discuss the roots of these things without solving any equation or plotting any graph. You see, that's the first question. We are still on the what? Determining the nature of roots without solving. So let me take another example for you guys. Let me take another example. Example number 3. So I'm going to do just 4 examples. But if you have any questions or you have more, you want me to explain more, or you have any questions, you can, under the link below, you can comment and we can do more questions for you guys so that you can really become good at this thing. So now I'm on example number 3. Let me do example number 3. So example number 3, we are discussing the nature of roots of x squared minus x is equals to 6. Okay. X squared minus x is equals to 6. Am I saying ax squared plus bx plus c? No, I want to say it means I have to take everything to what? This 6 must come to the other side. So I'm going to have x squared minus x minus 6 is equals to 0. Then this thing is in the form of ax squared plus bx plus c. Okay. Then what is the value of a? The value of a is 1. The value of b is what? It's minus 1. Then the value of c is what? Is minus 6. Okay? Okay. Then now I have my delta. Then delta is equals to b squared minus 4ac. Okay? Then you just substitute. What is the value of b? B is minus 1. Minus 1 squared minus 4. And then what's your a? And then what's your c? It's minus 6. So what do we have here? So basically we have 1 plus 4 multiplied by 6. What is 4 multiplied by 6? When you want it. What is 4 multiplied by 6? Is 24, ne? So 4 multiplied by 6 is what? Is 24. 4 multiplied by 6 is 24, which gives us 25. So multiplied by 4 is... Okay, so guys, we have punched it, ne? You can punch it in your calculator and check whether I'm right. So I'm getting 25. My delta is equals to 25. Ne? So now let us discuss the nature of roots. So since my delta is equals to 0, is greater than 0. That's what delta is equals to 0, is greater than 0. It gives us this thing is what? It's real. But we know when we have real, we have to go further. Again. So we have to go further. So when we go further, this delta again. So okay, let me use this marker. So this delta again is equals to, when you find the square root of 25, what is the square root of 25? You find the exact value of 25, which is 5. So the square root of 25 is 5. So it means this is a perfect square. This is a perfect square. This is a perfect square. And you know that a perfect square, it tells us the roots, they are what? They are rational. So when we say discuss, then our answer, what are we going to say the roots? They say determine the nature of roots. It means the roots of these things, they are real. Firstly, they are real because of this thing is greater than 0. Since this thing is also 25, this 25 is also a perfect square. They are what? They are rational. And then they are what? Lastly, they are unequal. So these roots are real, rational, and unequal roots. You see guys, so when you get real, it means you have to go further. If they are rational or irrational, they are all unequal roots. But if your delta is equal to 0, they are just equal roots. They're the same, it means the same root. Ne? Good. So I'm going to do the last example. Then I will go to the second part of type of questions that they ask in exam. So I'm going to go to example number 4. So I'm going to go to example number 4. So let us explore example number 4. So example number 4. So example number 4, we are having 4x squared minus 4x squared minus 4x plus 1. 4x squared minus 4x plus 1 is equals to 0. Yes. So this one, what I'm going to do, we're going to find the value of a which is 4, the value of b which is minus 4, the value of c is equals to 1. So we have 4 minus 4, and we have what? We have 1. So what we're going to do here, we're going to substitute. What is the value of b? So b is it's minus 4, 4 squared minus 4. Then what's the value of a? B is 4. Then c is what? C is equals to 1. So what am I getting? Where am I getting my delta? So when you substitute this thing, what are you getting? You are getting 0. So my delta is equals to 0. You see? So when my delta is equals to 0, we know that this thing, since delta is equals to 0, we have equal roots. So they are real. It means what you can say for this one, when delta is equals to 0, you can say they are real. And they are real and what? Equal roots. Okay, so now we're going to do the part 2 of it. Let us go to the part 2 of it. Opposite.